Okay, so let's now finish a very small thing called statistical test. Well, it's a very detailed area, so we will not look into too much of details about statistical tests. What we are really interested in is simply what is called the normality test, because everybody, all of you are familiar with the normal curve or the bell curve or the Gaussian curve, right? We also plotted that curve on a graph in one of the lectures. So just the normal curve corresponds to normality test. So what is that test? Well, if you are given any set of data, how close is the data to being on the normal curve, right? That is the normality test. It will give you an answer whether it is close enough to the normal curve or not. Okay, so that is one example of a statistical significance test, and we'll just look at the normality test and nothing else. Okay, so there are many other tests, but normality test is what is really easy for us. Okay, so before we do that, one thing to understand is now we are using the module of Scipy called stats. Okay, just like we had statistics as a Python module, remember? Here Scipy has a module called stats. Okay, so now if you take scipy.stats, it has a method called describe, which will actually tell you all the details about whatever data that you provide. Okay, so for example here, what all things are given, how many elements are there? It's like data is like an array. So how many elements or number of observations? What is the minimum maximum value? What is the mean? What is the variance? Skewness and kurtosis. Okay. Skewness and kurtosis are two numbers which are related to how close your data is to being standard normal. Okay. Skewness means whether the average is close to zero or not, or how far away it is from zero, because the standard normal average is zero, right? Kurtosis means what is the sort of asymmetry in the data. Standard normal bell curve, it is centered about the origin. So the skewness is zero. It is also symmetric about both sides of the line x equal to zero, right? So kurtosis is also zero. But then your data may not be symmetric about the middle part, not symmetric about the mean. Okay, so how asymmetric is it? That is indicated by kurtosis. Okay, so this is one example where they have actually given data from a normal distribution, okay, of size 100. So let's try that first. Okay, so once again import numpy as in p from scipy.stats, import describe. Okay, now how do they get data from the normal distribution? It's in the numpy. Okay, it's in the random module of numpy, right? So it is np.random. This we have seen, random module dot normal. Okay, normal is a method, and size means number of observations that you want. Okay, so that is 100. So take 100 observations at random with respect to normal distribution. That's what it says, and store it in the vector v. So v is equal to np.random dot normal size equal to 100. All right, and now what? Nothing else. Just print v dot describe or describe v. Yeah, describe v. Sorry, not v dot describe. Describe. Okay, so let's do this. Yeah, so it tells us that number of observations is 100 because size was 100. Minimum is this, minus 2 point something, maximum is this, 2 point something. Note that this is random observation, so you're not picking population, you're picking a sample from the normal distribution. So there will be small changes. So normal distribution is symmetric, so the minimum and maximum should be plus minus of the same number, right? But you will see this is minus 2.55 something, this is 2.46 something. but both are close to 2.5 in magnitude, right? That's because you're picking a sample and not the population. If you pick the population exactly, then it will have to be equal to minus 2.5 and plus 2.5. But you're picking a sample of size 100, so it is close to that. Okay, there will be small differences. Similarly, mean is supposed to be exactly 0, but you get mean to be 0.04 something because it is a sample of size 100. So it will be very close, but slightly off. Similarly, variance is supposed to be 1, but you get 1.13 because the size is 100. You're not picking the whole population, you're picking only the sample. Okay. Similarly, just as I said, skewness is also supposed to be 0, right? Because the mean is 0, right? But it is 0.003, just a little bit off. Similarly, kurtosis is supposed to be 0, but you have minus 0.2, just a little bit off. So you'll find these small differences from the exact value because you're not looking at the normal curve fully. You're looking at a sample of size 100 from the normal curve. Okay, but you can do this now for any other data. Okay, I can give you any large enough vector, sorry, and do the same thing. So let us change V to something else. Let's change V to np.array, some large number. Okay. Some array, some data. This will also have something, number of observations, 9, minimum, maximum, mean is 44. Variance is very, very large because on one side you have number as large as 2441. On the other side you have number as large as minus 2340. Variance is very large. Skewness is 0, close to 0, because this seems to be, I entered it very arbitrarily, but it seems to be fairly symmetric about origin. Kurtosis is 1, but okay, it's not about the origin, the shaping is not the same. Okay, it's not as symmetric as normal distribution. It's a bit skewed, or it's a bit shaped differently from the normal curve. Okay, so that is about skewness and kurtosis, and basically that's it about normality test. Okay, so normality test as such only looks at skewness and kurtosis. If you want to know how your distribution is different from the normal curve or how close it is to normal curve. Okay, you can simply take skewness and kurtosis by mentioning that separately. Okay, you don't need describe. So for example, I can just say print skew, print kurtosis v. Okay, skewness. Did I get it wrong? Oh, sorry, I did not import this. Sorry. You also have to import this. So describe skew. Yeah, all from Scipy. Okay, so the skewness value came separately. Kurtosis value came separately. Okay, that we have done. What about normality test? Normal test tells you the same thing in a slightly different language. Okay. So let's do that. So again, now if we say print normal test, it will give you error because again I have to import it. Okay. So import normal test. Okay, so test is valid only for n. You have to give some large number of observations, but that's like a warning because otherwise this is not behaving nicely. So kurtosis test is valid only for n greater than equal to 20. So if you give large data, then not a big problem. So maybe I can include some more. Do we have enough? Yeah, now we have more than 20. And it tells you what is the statistic, what is a p-value. Okay, what does this mean? So the statistic and p-value are obtained by the skewness and kurtosis numbers only, not very different. But you're supposed to read essentially only the p-value. If the p-value is close to 0, then this distribution is close to being normal. Okay, but the statistic also should be close to being 1 in some sense. Otherwise, it is not. So, for example, it is now p-value is 2 point something something into 10 raised to minus 12. So this is very close to being normal in that sense. But statistic is 53, so the magnitude is not close to being normal. The absolute values of the numbers are not close to being normal, but as far as symmetry is concerned, this distribution is close to being normal. Okay. Now let's repeat this for the normal test itself, and then you'll get a better idea. Right. And we have to import these. Yeah. So now both values are small. So 0.3 and p-value is 0.8. Right. But this is for a sample. For the fold population, it will be the exact values 0. Okay. So now both magnitude wise as well as symmetry wise, this is close to the normal curve because it was sampled from the normal distribution only. Okay, so it will be close to the normal, right? So that is how you measure how your given data is close to the normal curve. That's called normality test. Okay, main things to note here is that for a normal curve, there is no skewness, there is no kurtosis. So the closer those corresponding values are to 0, your given data will be closer to the normal distribution. Otherwise, they will be far away. Okay. So that's all about statistical test or normality test that I wanted to talk to you about. So I'll stop here now.